All right, so get this. Today, we're taking a deep dive into something that sounds like it's straight out of science fiction. Quantum teleportation.
Yeah.
But before anyone starts picturing, beaming across the galaxy like in Star Trek,
Right.
let's bring it back down to Earth and talk about the real science here.
Yeah, the really fascinating thing here is we're not talking about physically transporting matter. Like, we're not beaming people up or anything like that.
Right.
We're talking about transferring quantum states.
Okay.
So think of it like the fundamental blueprint of a particle. It's about information, not like physical transportation.
Okay, so it's more like information transfer, not the actual physical object itself.
Exactly. Yeah.
And this information transfer is happening right now. It's not just theoretical anymore.
Oh, absolutely.
We've got a whole bunch of sources for you guys today. Everything from like dense scientific papers to some news articles that break it down a little more simply, even some YouTube explainers that we found.
Right.
They all point to this field just like exploding with breakthroughs right now.
Yeah, it's a really fascinating time to be following quantum teleportation because it's moving so quickly. It's really building upon decades of research, though.
Okay, so let's unpack this a little bit because I think, at least for me, the thing that is most mind-boggling about all of this is this concept called quantum entanglement.
Right.
I've read about it, but it still feels like magic to me.
Yeah, I understand that feeling. Even Einstein called it spooky action at a distance. And it's really ironic because his work, in a way, kind of laid some of the groundwork for this field. But essentially, entanglement is this idea that two particles can be linked.
Okay.
No matter how far apart they are. So that if you do something to one particle, it instantly affects the other one.
So give me an example. So like, let's say we have two entangled particles. One is here on Earth.
Yeah.
The other one is chilling out on the moon.
Okay.
If I change something about the one here on Earth, its entangled partner on the moon, it reacts instantly.
Exactly. It's like they're two sides of the same coin, even if they're, light years apart. You flip one to heads, the other one instantly flips to tails.
Wow.
But here's the crucial point. We're not actually transmitting information faster than the speed of light.
Okay.
It's more about the fact that these two particles exist in this shared state.
Okay.
They have this connection that transcends our everyday understanding of space and time.
Okay, that kind of blows my mind, but I'm starting to get it.
Yeah.
So how did we go from this, like, science fiction daydream to actual scientists in a lab seriously working on this? It's not like they built a transporter room somewhere, right?
Well, not quite. I mean, yeah, the concept of teleportation has captivated us for ages.
Right.
But the scientific journey, like the serious work on this, it really started in the 1990s.
Okay.
And it was built on all this groundwork in quantum mechanics. And, there's this really cool experiment in 1997, and it proved that teleporting the quantum state of a photon was possible.
Wait, so they actually teleported something?
They did.
Like, in real life?
Yeah, it was just a single photon.
Okay.
And it only traveled a few meters, but it proved that the principle worked. And, things have advanced a lot since then.
That's incredible. So how far have we come since then? Or we're talking teleporting across rooms, across cities.
Think bigger.
Okay.
In 2017, there was this team of Chinese scientists, and they used a satellite called Metis.
Okay.
And they teleported entangled photons over 1,200 kilometers. That's shattering previous records. We're talking intercontinental quantum teleportation.
Okay, that's just wild.
Okay.
So just to be clear, we're teleporting information, not physical objects. But what does that actually mean for, the average person listening to this? What are the real-world implications of all of this?
Well, the implications are huge, and they touch on almost every aspect of our lives. But I think one of the most exciting applications is the potential for a quantum internet.
Okay.
A network that is so secure, it would make our current systems look like child's play.
I think everyone listening to this can get behind that. In this age of data breaches and, all these cyber attacks, who wouldn't want a truly unhackable internet?
Exactly. And with something called quantum key distribution, any attempt to intercept data would actually disrupt the transmission. So it would alert both parties to the intrusion. It's like having an alarm system built into the very fabric of the data itself.
So instead of reacting to hacks, we would have a system that would prevent them from happening in the first place.
Precisely. But it goes beyond security. Imagine a world with instantaneous data transfer, no matter the distance.
Yep.
No more lag, no matter where you are on the planet.
That would completely change how we communicate, how we work. Even how we experience the world, right?
Absolutely.
So we're talking about a fundamental shift in how information flows around the globe.
We are, and that's just one application. We haven't even touched on healthcare or computing or even,
Hmm.
the theoretical possibility of matter transportation.
All right, now you've really piqued my interest. Let's dive into those next.
Let's do it.
Yeah.
This is just the beginning of exploring this astonishing world of quantum teleportation.
Hold on to your hats, folks. Things are about to get really interesting. All right, so we've learned that quantum teleportation, it isn't just a fantasy anymore.
Right.
It's this rapidly evolving field, and it just has all this mind-blowing potential.
Mm.
And one of the things that I'm really fascinated by is its applications in medicine.
Yeah.
It seems like we're on the verge of a revolution in healthcare.
It's true. The implications for healthcare are huge. We're not beaming patients up to, like a Star Trek sick bay just yet.
Right.
But the way we diagnose and treat diseases is definitely about to change in a really big way, all thanks to quantum teleportation.
One of the things that really stood out to me when I was doing research for this was this thing called quantum imaging.
Right.
Can you explain what that is and how teleportation fits into that?
Yeah, think of quantum imaging as a way to see inside the human body with incredible detail and clarity. It uses entanglement and quantum state transfer to create images that are way more detailed and sensitive than anything we can get with our traditional methods.
So instead of relying on I don't know, X-rays or MRIs,
Mhm.
which have limitations and potential risks, we could have this totally new way to see what's happening inside the body.
Exactly. Imagine detecting cancer cells when they're just starting out or, watching the brain work in real time.
Wow.
It could completely change how we understand and treat really complex neurological disorders like Alzheimer's, Parkinson's.
That's incredible. And you mentioned real-time visualization.
Yeah.
What kind of impact did that have on surgery or other medical procedures?
Oh, the possibilities are just massive.
Mhm.
Imagine surgeons being able to monitor blood flow or nerve function
Right.
during these really delicate operations with pinpoint accuracy, or even think about remote surgery,
Hmm.
where a specialist could be thousands of miles away.
Yeah.
And they could use quantum information to guide a procedure, using robotic instruments.
It sounds like we're talking about a level of precision and control that was unimaginable a few years ago.
Oh, absolutely. And it's not just about the technical advancements, it's also about patient safety. We could reduce recovery times,
Right.
quantum imaging uses lower energy levels than our traditional methods.
Hmm.
So it minimizes the risks that come with radiation exposure.
That's a huge benefit, especially for, vulnerable patients, people who need frequent imaging.
Hmm.
It seems like this could democratize access to quality healthcare, too.
It absolutely could. One of the things that's so exciting about this technology is that it could break down these geographical barriers.
Mm-hmm.
Imagine a rural clinic in the middle of nowhere,
Right.
and they could instantly share a patient's medical images with specialists anywhere in the world. So we could bridge the gap between people who don't have access to the best medical care and the experts, no matter where they are.
That's amazing. A world where everyone, regardless of where they live, has access to the same level of care. It seems like this could also play a huge role in personalized medicine, right?
Yeah.
Tailoring treatments to each person's unique, genetic makeup.
You're exactly right. Personalized medicine is another area that's ripe for transformation. So imagine being able to analyze a patient's DNA
Okay.
and then use quantum teleportation to transmit the exact quantum information you need to make a drug or a therapy that's just for them.
Oh,
That's the ultimate precision medicine, right?
that sounds like something out of science fiction.
I know.
But it's becoming more and more possible as research moves forward. It's really exciting to think about a future where treatments are more effective, more targeted, fewer side effects, and better outcomes for patients.
It is, and those are just some of the ways quantum teleportation could reshape healthcare. From drug discovery to regenerative medicine, the possibilities are pretty much endless.
Okay, so it's clear that we're on the cusp of a big paradigm shift in medicine.
Okay.
And quantum teleportation is right at the center of it. But let's switch gears for a minute to
Okay.
talk about another area where this technology is starting to make waves: quantum computing.
Ah, yes. Quantum computing. It's a field that a lot of people find kind of confusing, but it has a lot of promise for solving these really complex problems that humans face.
I have to admit, it's definitely an area that I'm still trying to wrap my head around. Can you give us a little crash course on how quantum computing works? and how teleportation plays into it.
So think of quantum computers like a totally new kind of computer. They're not like our classical computers that use bits, which are
Right.
either 0 or 1.
Okay.
Quantum computers use these things called qubits, and they can be both 0 and 1 at the same time.
So it's not just 0 or 1, it can be both.
Yeah.
That seems almost impossible.
Yeah. It does. It's like this really weird part of quantum mechanics, but it's real. It's been proven, and this is where quantum teleportation comes in. One of the biggest challenges with quantum computing is making them bigger.
Okay.
Building networks of these super powerful but also really fragile machines that can all work together.
So we need to connect these quantum computers without messing up their delicate quantum states.
Yeah.
And that's where teleportation helps.
Exactly. If we use quantum teleportation to move information between these quantum computers, we can create a kind of quantum internet just for these machines. So imagine a global network of quantum computers all working together to tackle problems that regular computers just can't handle.
What kind of problems are we talking about? What could this kind of quantum computing power do?
The possibilities are kind of mind-blowing. Think about designing new drugs to save lives, modeling climate systems so we can understand and fight climate change, creating new materials that we've never seen before, or even understanding the universe on a deeper level.
So we're talking about a whole new era of scientific discovery and technological innovation. And it's all powered by combining quantum computing and teleportation.
We are. And while there are definitely still technical challenges, there's so much potential here that it's got scientists, engineers, entrepreneurs all really excited.
It's clear that quantum teleportation isn't just about moving things around. It's a fundamental tool for controlling and moving information in ways that we're just beginning to grasp.
Right. And that leads us to maybe the most mind-blowing and honestly the most speculative possibility of all, teleporting physical matter.
Okay, now we're getting into science fiction territory, right? Like, beam me up, Scotty.
I know, it sounds crazy. It's definitely the most theoretical application of all this.
Right.
But some physicists think it might actually be possible.
Wow.
The idea is that if we can transfer quantum states, maybe, just maybe, we can do the same thing with bigger objects, even potentially people.
Hold on. Are you saying that one day we could teleport ourselves across huge distances, like step into a machine and appear somewhere else?
It's a long shot for sure. The technical challenges are huge. And then there are all these ethical questions, too. We're talking about taking apart and putting back together matter at a subatomic level. What does that mean for our identity? For our consciousness?
It's almost too much to even think about. But let's say, just hypothetically, that we could do it.
Okay.
What would teleporting matter mean for society?
It would change everything, wouldn't it?
Wow.
Imagine a world with no airplanes or cars, where we could travel anywhere instantly. Think about what that would mean for global commerce, tourism, even just our personal relationships.
It would revolutionize how we interact with each other and the world around us.
Hmm.
But I imagine there would be a lot of problems too, right?
Definitely.
What about security? Or the potential for governments or corporations to abuse this kind of power?
Absolutely. The ethical questions are huge. But even if teleporting people stays in the realm of science fiction, just teleporting objects would be amazing. Imagine instantly transporting goods around the world. No more shipping. A totally different kind of supply chain.
That would be amazing from a logistical standpoint.
Hmm.
But what about the economic impact? What about the people who work in transportation?
Yeah, that's a really good point. It seems like with every potential benefit of quantum teleportation, there are also consequences that we have to think about.
Right. Technology doesn't exist in a vacuum. It comes with both opportunities and challenges, and we have to understand both sides.
Exactly.
Well, I think we've already given our listeners a lot to think about. But we're not quite done yet. We've talked about the benefits of quantum teleportation, but now let's dive into some of the ethical concerns and the potential impact on society.
I'm ready when you are. It's so important that as we make these amazing breakthroughs, we don't just focus on the how. We also need to think about the why and the what if.
Exactly. Stay tuned, everyone. Things are about to get really interesting. We've spent this whole deep dive exploring all these incredible things that quantum teleportation could make possible.
It really is amazing.
Like changing how healthcare works, unleashing the power of quantum computers. We even touched on this, like far-out idea of teleporting like physical stuff.
Right, like actual matter.
Yeah. But it's important to remember that any technology with this much power comes with some ethical questions too.
Oh, absolutely. It's like we've got this amazing tool, but we need to figure out how to use it the right way.
Exactly. And we talked a little about the economic side of things.
Yeah.
But what about privacy? In a world where information can be sent anywhere instantly and securely, that seems like a huge concern.
You're right. Privacy is going to be a big deal. If we have widespread quantum teleportation, we'll need to rethink data security and privacy completely. Like, imagine if governments or corporations could just access anyone's data anywhere at any time.
That sounds like a nightmare. It's
Ah,
like something out of a bad sci-fi movie.
I know.
Our personal information, our medical records, our finances, all of it could be at risk if we don't put some safeguards in place.
We definitely need to be thinking about strong encryption, maybe keeping data in lots of different places instead of all together, and probably even new laws to protect people's privacy when information can travel so fast.
It sounds like we need ethicists and lawmakers involved in this right alongside the scientists.
Definitely.
And privacy isn't the only ethical thing to think about, right? What about fairness and equal access? Wouldn't a technology like this just make existing inequalities worse?
That's another really important point. We have to make sure this technology doesn't become something only rich or powerful people can use. Like, imagine a world where only some people can teleport, or where those life-saving medical treatments we talked about are only available to a select few.
That would be terrible. It would create a whole new level of injustice in the world. We need to be thinking right now about how to make this accessible to everyone, no matter how much money they have or where they live.
I completely agree. We need policies that make sure everyone has fair access, maybe through things like government funding, partnerships between companies in the public sector, or even making the technology open source so anyone can use it. We can't let this amazing technology just make the gap between the rich and the poor even bigger.
It seems like figuring out the ethical side of quantum teleportation will be just as tough as the scientific breakthroughs themselves.
Oh, yeah, for sure.
It's a good reminder that progress isn't just about what we can do, but also about what we should do.
Exactly.
We've covered so much in this deep dive, the science, the potential, the ethical challenges. It's a lot.
Yeah.
What do you think is the most important takeaway for our listeners?
I think the biggest thing to remember is that we are right on the edge of a truly world-changing era. Quantum teleportation could revolutionize everything, but it's up to us to make sure that future is a good one.
It's a future full of possibilities, but it's not set in stone. We have to build it, and we have to do it with ethics, fairness, and a deep understanding of what this incredible technology means.
You said it perfectly. As we go further down this road, we have to stay aware, keep asking questions, and be committed to using this power for good.
I think we've given our listeners a lot to chew on. It's definitely clear that this is a journey that needs both our scientific brilliance and our moral compass.
It is, for sure. It'll be a journey with both amazing successes and some tough challenges, but it's a journey worth taking.
To everyone listening, thanks for joining us on this deep dive into quantum teleportation. We hope you learned something new and that maybe we've sparked your imagination about the future. Until next time, keep exploring, keep asking questions, and keep imagining the kind of world we want to live in.
And keep dreaming big.
See you all next time.